Welcome to a new session on Shikshana Taranga by Cloud Tutors, a program to help grade 10 students to prepare for board exam. Today's topic is polynomials. So let's get started, and the weightage given to this chapter is 4 marks. And the important points that needs to be remembered is zeros of a polynomial, relationship between zeros and coefficients of polynomial. So basically you can expect questions based on these points. Okay, polynomials, these are the points that are being covered in this chapter. Types of polynomial, division algorithm, zero of a polynomial, and the relationship and how to plot a graph of a polynomial. We'll look into this in few minutes. First thing is, before we say go to a polynomial, let's understand what is an algebraic expression. So let me take an example. We all know the perimeter of a circle. When I say perimeter of a circle, I mean nothing but a circumference of a circle, that is 2 pi r. And what is the value of pi here? It is nothing but 2 into 22 by 7 into r. And pi can be even, I can take the value as 3.14. Alright, so it doesn't matter. So what I'm trying to say here is 2 into 22 by 7. Will it change? Will it vary for different types of circles? No, right? That is why we call this as a constant. 2 into 22 by 7 is called as a constant. What about r? For different varieties of circle, the value of r keeps changing. Yeah? So that is why we call that as a variable. When a constant and a variable come together, they form an expression. In this example, it is a simple expression. Okay, so if I take another example, say 3x square plus 2x plus 7. Here it is a combination of more than 2 or 3 terms, right? When I say term, what are term? So this, a coefficient of a variable, that is 3. When I say coefficient, remember, I'm talking about the factor that is multiplying the other. So if I say coefficient of x square, it is 3. Coefficient of 3 would be x square. The vice versa. Basically the factors of those constants and variables. So here this is called as term, or I can also say call it as algebraic term. So more, and again this is a term, and again even 7 is called as a term. Now here I have combination of 3 terms. 3 terms together form an expression. So, or I can also say as algebraic expression, in general expression. Okay. So when I say expression, what is an expression? It is nothing but combination of one or more than one term separated by a mathematical operator. What are mathematical operators? These are mathematical operators. It can be addition, subtraction, multiplication and division. These are all mathematical operators, or should I say plus, minus, into and division symbol. Okay, they are mathematical operators. When more than 2 terms are separated by mathematical operators, they are called as expressions. Now what is a polynomial? Let me take another example. X plus 1 by x. So when I say x plus 1 by x, I can rewrite this same expression as x. Definitely it's an expression, mind you. So it's an expression. When I can rewrite this as x plus x power minus 1. Now I call this as an expression but not as a polynomial. Do you know why? Because a polynomial will not have a negative power. When I say negative power, it has to be positive. It cannot have. If it has a negative power, it is an expression, no doubt about it. But it is not a polynomial. Clear with that? Definitely the first example is a polynomial. Okay. And the second example is not a polynomial. Now let me take another example. X plus root x. Here root x. Now how can I write root x? So this can be written as x plus x power 1 by 2. I said, is this a polynomial x plus root x? You might say yes, ma'am. But I would say no. Why no? Because, ma'am, it is having a positive power, then why is it still not a polynomial? Definitely, I said, whenever the power becomes negative, it is not a polynomial. Now, I am saying now it is plus, positive power, but it is a rational number. 1 by 2 is a rational number, right? The power is in the form of P by Q form. But for a polynomial, the power has to be non-negative integer. When I say non-negative integer, it can be minus 3, non-negative. So I cannot include negative numbers, right? So it has to be something starting from 0, 1, 2, 3, 4 and so on. Okay, so basically I'm talking about whole numbers, non-negative integers. It is all right if we have the power as 0, no problem, but it just should not be less than 0. Okay, with this concept, let us define a polynomial. So in generic form, we can write polynomial as P of x. So polynomial of x with a variable x. So wherein a0 plus a1, a2, a3, an minus 1, an, right? It is all being multiplied to a variables. Here, all this a0, a1 and a2 and so on are all real numbers. Bam. You just said it has to be non-negative integers, right? I am talking about the power. The powers are definitely non-negative integers. Here it is 1, right? It's just that whatever you're multiplying can be a rational number, irrational number, doesn't matter. Okay, so I say that all constants can be real numbers, but the degree or the power of the variable should be non-negative integer. That and it can be represented as P of x, F of x and G of x. Yeah. So with this, let's see a few examples and say if it is a polynomial or not a polynomial. All right. So the first expression you can see, definitely it's an expression, right? So basically all expressions cannot be polynomial, but all polynomials are definitely expressions. Remember that. Okay. So first question, 3x plus 5. It's a polynomial. And the next one, definitely again, this is a polynomial. Okay. And the next expression, see here, you have a rational number here and an irrational number here. Do you think it's not a polynomial? But that is not our concern. We have to observe the degree of the variables. When there is nothing, it means it is 1. Okay, it is a polynomial. In the second example, x power 1 by 2 plus 2. I can rewrite the same expression as x power 1 by 2 plus 2. Is it a polynomial? No, because the degree of the variable is half, right? It is a rational number and not negative integer, non-negative integer. Okay, and in the next, it is x plus x power minus 1 and minus 5. So it is again not a polynomial. Okay, now the examples which are polynomial, let us see what is their highest degree. Highest degree here is when it is nothing, I can say degree is 1. Degree is 1. And in the next example, it is 2 here and it is 1. What is the highest now? Is it 2 or 1? Definitely 2. So here degree of the polynomial is 2. And the next expression, here degree is 3. Okay. Now let us understand what makes a polynomial with degree 1, degree 2 and degree 3. Okay. Now when I say degree 1, it is called as linear polynomial. Okay. I can write this as x plus 2, x plus y plus 5, doesn't matter. Okay, how many terms I'm having doesn't matter, but what is the degree or the power? Definitely it matters when you classify a polynomial based on its term. When you classify a polynomial based on its terms, then you have monomial, binomial, trinomial and so on, right? But when we talk about types of polynomial based on its degree. Then you have linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial, and so on. For us, right now, we will concentrate only on the types of polynomial, classification based on its degree. Okay. So, linear polynomial. So, whenever I have a degree of 1, I call that as a linear polynomial. Now, how many variables do I have here? It is 1. Here I have 2 variables, doesn't matter, but the highest degree is still 1. So it is a linear polynomial with degree 1. Next one, quadratic polynomial. What is a quadratic polynomial? Whenever the degree of the expression is 2. So here degree is 2. So I say x square plus 3x plus 4 is a quadratic polynomial. One more example, 7x square. Just the term. I know it's a monomial, but doesn't matter. It is still the highest degree is 2, and therefore it constitutes the quadratic polynomial. Now let's look into this cubic polynomial. What is a cubic polynomial? Whenever the highest degree is 3. So for example, 7x cube, just 7x cube is a cubic polynomial. 7x cube plus 2x square plus 3xy. Okay, I can have more than one variable, doesn't matter. But the degree should, whatever the degree is, the highest degree, it defines the degree of the polynomial. So it belongs to that category now. Okay. Now with this understanding, let's see, find the value of x. For this, I have just taken an example here. P of x is equal to x square minus 5x plus 6. Now we have to find the value of P of x at x is equal to 0. First exam. So wherever I have x, I will replace the value of x with 0. So in the first example, it will be P of P of 0 is equal to 0 square. So it was x square. I have written it as 0 square minus 5x. Here 5 into 0 plus 6. Alright. So how do we simplify this? 0 square is 0. Anything multiplied to 0 is also 0 and plus 6. So P of 0 gives me the value of plus 6. Okay. Now let's take another example where the value of x is 1. So what happens to P of 1? P of 1 would be 1 square minus 5 into 1 plus 6. So that is when I simplify 1 minus 5 plus 6. So 1 minus 5 is minus 4. Minus 4 plus 6 is plus 2. So P of 1 is plus 2. Okay. In the next example, x is 2. So P of 2 is equal to 2 square minus 5 into 2 plus 6. So 2 square is 4. Minus 5 into 2 is minus 10 plus 6. So it is 4 minus 10 is minus 6. Minus 6 plus 6 is 0. So P of 2 is 0. Next is P of minus 1. What is it? Minus 1 the whole square minus 5 minus 1 plus 6. So that is minus 1 whole square is 1. Minus 5 into minus 1 is plus 6 and plus 6. So it is 12 plus 1, 13. So P of minus 1 is 13. Here I have just taken random values of x. There is no hard and fast rule that I have to take only this value. No. You can take any value of x until and unless not asked in your question paper. Okay. Whatever is asked, you have to substitute. Otherwise, you can assume any value of x and find the value of P of x. Now, as you all can observe, for one of the expression, P of x, that is P of 2, is 0. That means for x equal to 2, P of x is equal to 0. What does this mean? That means that it is a factor. It is one of the factors. Now when I say factors, what does it mean? So for this particular value, that is 2, for the value, for x value being 2, it cuts the x. If I say this is my x-axis, this is my y-axis, it means that it cuts the x-axis at 2. Okay, so if I have to plot, this would be, if I say this is 2 and this is 1, it is cutting the x-axis at 2. When I plot this readings on a graph and it cuts the x-axis, it means that it is a 0 or I can also say as root of the polynomial. So now let's understand what do you mean by roots of a polynomial or 0 of a polynomial and different instances of it. Okay, when I say different instances at different position, what happens if it cuts at different positions? See here, it is cutting the x-axis at -2. Here it doesn't even touch the x-axis, and here it cuts the x-axis at +3. Okay, so here there are 3 examples wherein these graphs are cutting the x-axis at different positions. Here observe, here this is an example of a linear polynomial. When I say linear polynomial, the degree is 1. So whenever you have a degree 1, it means that it might have it might cut the x-axis at max at 1 position. See, as you all can see, here it is 1 position, here also it is in 1 position. But here it doesn't cut at all. So what does that mean? It means that it might not have any zeros at all. So maximum it can have 1 0 or no zeros at all. That is all it means. Okay. So let's see the next type. Here you have got a U-shaped graph, and this U-shaped graph is also known as parabola. When I say parabola, for which kind of equations do you get a parabola? It is for quadratic polynomials. So for quadratic polynomials, you get parabolas. Parabolas are U-shaped. Now, as you all can see, again, here it cuts the x-axis at 1 position, here at 2 positions. So here it is not cutting at all. There is no contact with the x-axis at all. So what does this mean? So for a quadratic polynomial, at max it can have 2 zeros or less than 2. 2, 1 or nothing. Okay. And for a cubic polynomial, let's see. So what is the guess? This is an example of a cubic polynomial, and for the same expression I have plotted this graph. So as you all can observe, it cuts the x-axis at 3 positions. So for a cubic power polynomial, it can have 3 zeros max or no zeros at all. So remember the degree of the polynomial. The degree of the polynomial indicates how many zeros a polynomial can have or how many roots it can have. So what I mean here? The degree of the polynomial indicates how many times this equation, when plotted on a graph, cuts the x-axis. Clear with this concept? Let's see the relation of a coefficient. Now we all know that generic equation of a quadratic polynomial, right? Generic form of a quadratic polynomial. It can be written as p of x is equal to ax square plus bx plus c. Yeah? And where a is not equal to 0. What happens if a is 0? Have you all thought of it? When a becomes 0, this factor is, becomes 0. When this becomes 0, you are left with bx plus c. And what is bx plus c? It becomes a linear polynomial. So it's very important that you mention a is not equal to 0 for a quadratic polynomial. Alright, so this is the generic form. Now I am dividing the entire equation with the coefficient of x square. So what is the coefficient of x square? It is a. Right? So when I divide the entire equation with the coefficient of x square, that is a, I get x square plus b by ax plus c by a equal to 0. Now if I say alpha and beta are the roots of p of x. See here, quadratic polynomial. So how many roots will it have? 2, right? So 2 roots, I'm assuming it to be alpha and beta. So alpha and beta be the 2 roots. So what are the values of alpha and beta? So what will be the factors of p of x? It would be x minus alpha and x minus beta. So these are the roots. So I can rewrite this generic equation form of polynomial as x square minus alpha plus beta into x plus alpha beta. Now what is this alpha plus beta? Let's see it here. Alpha plus beta is nothing but minus b by a, and alpha beta is equal to c by a. And that means that sum of the roots is alpha plus beta and product of the root is alpha beta for a quadratic polynomial. So what happens for a cubic polynomial? This is a cubic polynomial. So how many roots can a cubic polynomial have? It can have 3 roots, right? Here again let us assume it as alpha, beta and gamma. The third root here is gamma. Now how would I express the same polynomial in terms of roots? Is x cube minus sum of zeros. Sum of zeros is what? Alpha plus beta plus gamma, okay, into x square plus into sum of products of zeros taken 2 at a time. So what does that mean? Alpha beta, beta gamma and alpha gamma, okay. So this is 2 roots at a time. Then minus product of zeros. Product of zeros is alpha, beta, gamma. Okay. So with this information, let's quickly do this question and then we will move to the practice questions. Okay. Here let us match the graphs shown below with the degree of the polynomials. As I all said, what is that you need to see in a graph? At how many positions is the graph cutting the x-axis or crossing over the x-axis? Here it is 1, 2 and 3. So when a graph is crossing over the x-axis 3 times, so what does it mean? The degree of the polynomial is 3. Very good. So it is 3. And in the next graph, as you all can see, it is cutting the x-axis at 2 positions. When it cuts the graph at 2 positions, it is degree of polynomial is 2. Here it is crossing over at 1 position, so it becomes 1. So degree of the polynomial is 1. So first example is cubic and this is quadratic polynomial and this is linear. And in see, when you're plotting these graphs, definitely cubic and quadratic can be done freehand. But when I say linear, the lines should be a straight line. You cannot have a breaks. What do I mean by a break? See, for example, I'm plotting a linear polynomial. So I cannot have a line which is like this. Like this. That means here you can see there is slightly shift in the position. Then it is definitely a line graph, but not a linear graph. Linear means straight line. Okay, line it's definitely it is a line, right? It is a line, but it is not a straight line. So therefore there is a difference between linear graph and line graph, and for a polynomial we always plot a linear graph and not line graphs. I hope this is clear with you all. Okay, next moving on to the practice questions based on previous year papers. Okay, first question is write the number of zeros of the polynomial p of x is equal to x cube plus 2x square plus x plus 6. Okay, so here p of x is a what? Let me rewrite the expression. Is equal to x cube 2 plus 2x square plus x plus 6. Okay, this is my p of x. So I want to find how many zeros will this have. We just learned few seconds back. Zeros of the polynomial is determined by the degree of the polynomial. So here what is the degree of the polynomial? It is 3. Highest degree is 3. Definitely we have 2, we have 1 here, and here it would be x to the power of 0 as well, right? But we have to concentrate only on the highest degree. Here the highest degree of the polynomial is 3. So therefore number of zeros is equal to 3. Alright, so now let's look into the next question. Next question is, if one of the zeros of the polynomial is 2. Polynomial given here is what? Let me rewrite the polynomial first. It is x square minus x plus k. Okay, if one of the zeros of the polynomial p of x is 2, that means one of the factors is 2, then find the value of k. We have to find the value of k. What is the value of k? How do we find this? Say here they are saying one of the factors is 2. So that means x is equal to 2. Correct? So let's substitute here. So what is p of 2? It will be 2 square minus 2 plus k. Now one more thing. If p of x is, they are saying pakka, x is equal to 2. That means it is a factor. So what will happen to p of x? Then p of x should be equal to 0, right? So we equate this given expression to 0. So what happens? 4 minus 2 plus k is equal to 0. Then 4 minus 2 is 2 plus k is equal to 0, or k is equal to minus 2. We have found the value of k. So the right answer here is B. B option is the right answer, where k is equal to minus 2. Okay, let's see the next question now. If alpha and beta are the zeros of a polynomial such that alpha plus beta is equal to 6 and alpha beta is 4, then write the polynomial. Here alpha plus beta are the roots, right? Is equal to 6 and alpha beta is equal to 4. Please make an habit of writing what is given to you first. Okay, now we know the generic way of when the roots are given, right? When the sum of the roots and product of the roots are given, what is the generic way of writing this? Let's write that. The required polynomial is what could it be? Polynomial is p of x is equal to x square minus alpha plus beta into x plus alpha beta. Now it's simple substitution. P of x is equal to x square minus 6x plus 4. This is our required polynomial. Alright, so let's see the next question. Does the polynomial a power 4 plus 4a square plus 5 have real zeros? Before going to if it has a real zero or not, observe here, previously whatever questions we took up had the value of the variable as x. Here it is a. Here the variable is a and not x. And we have not seen any examples relating to quadratic, biquadratic. When degree is 4, it becomes biquadratic polynomial. So what I can do here is, let me make an assumption here. See here, this expression a power 4 plus 4a square plus 5 can be rewritten as a square into a square plus 4a square plus 5. Why did I do that? Because observe here, I had a term a square here, right? I had a square here. So what I will do, I have a square here. So I have split this first term in as a square into a square. Okay, you will know in a second why I did that. Here I can say let a square be equal to x. So I'll make an assumption, let a square be equal to x. So what happens to the expression now? It becomes x into x plus 4x plus 5. Okay, now this is a polynomial, right? If this is p of x. So here also I'll write p, oh sorry, this is here, it is p of a. Now p of x, okay, is equal to, p of x is equal to x square plus 4x plus 5. Now it is in our way, right? Wherein we learned variable x. Now the question has become simplified. Now let's compare this. We have to find if it has real zeros or not. So how do we do that? Let's compare this to the generic form of a quadratic polynomial. What is it? So it is ax square plus bx plus c. Okay, wherein my a is equal to 1, b is equal to 4, c is equal to 5. Now why do we need to know all this? Because we have to find, does it have a real zeros or not? For that I need to find the value of d. Now what is d? D is the discriminant which indicates if a polynomial will have a real zeros or not. So let's see that. Here d is given as b square minus 4ac. Okay, now substituting the value, d is equal to 4 square minus 4 into 1 into 5. So 4 square is 16 minus 4 into 5, 1 into 5 is 20. So 16, the value of d is minus 4. That means the value of d is less than 0. Value of d is less than 0. So whenever the discriminant value is negative, or should I say less than 0, it means that the given polynomial does not have real zeros. So therefore, given polynomial does not have real zeros. Let me write this. This is equal to d here. Okay, does not have real zeros. All right. So let's move on to the next question now. If alpha and beta are the zeros of the polynomial, p of x is equal to 3x square minus 12x plus 15, find the value of alpha square plus beta square. Now here alpha and beta are the zeros of the polynomial. So let's do it. P of x is equal to 3x square minus 12x plus 15. So first let us find what is the value of alpha plus beta and alpha beta. Alright. So, and I need to compare this to the generic form, that is ax square plus bx plus c. So from this I can say a is equal to 3, b is minus 12 and c is 15. So sum of the roots is what? Equal to alpha plus beta. This is equal to minus b by a, that is equal to minus 12 by 3, and that is nothing but minus 4. So alpha plus beta is equal to minus 4. Next is product of the roots. Product of the roots. So what is the product of the roots? That is equal to alpha beta, and that is equal to c by a. And now what is the value of c here? 15 by 3. So alpha beta is equal to 15 divided by 3 is 5, right? Yes. Now we know the values of alpha, we know the value of beta. Now let's find the value of alpha square plus beta square. So, ma'am, how do we do this? Because we know the value of alpha and beta, right? Not the alpha and beta, sorry. We know the values of alpha plus beta and alpha beta. We do not know the values of alpha and beta individually. So what do we do now? Remember the identity a square plus b, a plus b the whole square. Let me write that. A plus b the whole square is equal to a square plus 2ab plus b square. Correct? Now I'll use this identity. What should I do? We have to find the value of a square plus b square, right? Here my A and B are nothing but alpha and beta. I will retain A square plus B square on one side and transpose this 2AB to the other side. What will happen? It is A plus B the whole square minus 2AB. Okay. Now let's rewrite this equation in terms of alpha and beta. So this would be alpha square plus beta square equal to alpha plus beta the whole square minus 2 alpha beta. Alright. Here now let's substitute. We know the values of alpha plus beta. We know alpha beta, right? We just found that out. So alpha plus beta is minus 4. Alpha beta is 5. Let's substitute the values. So it is minus 4 the whole square minus 2 into 5. So on simplifying it is 16 minus 20. Sorry, 2 5s is 10 and not 20. Yes or no? Right? 2 5s are 10. So alpha square plus beta square is equal to 16 minus 10 is 6. Right? Now let's look into the next question. Find the zeros of the polynomial f of x is equal to x square plus 7x plus 12 and verify the relationship between the zeros and the coefficients. Let's do it. So let's say f of x. What to say? They have already said f of x is equal to x square plus 7x plus 12. Now again, comparing it to the generic form, ax square plus bx plus c, yeah, where a value is 1, b value is 7 and c value is 12. Now we have to verify the relationship between the zeros and the coefficient. So how can we find it? Okay, for that, what we can do here is let's find the relationship, that is sum of the roots. What is sum of the roots? Alpha plus beta, and this is given as minus b by a. So alpha plus beta is equal to minus 7 by a is 1, so it is minus 7. Now let's see the product of the roots. So product of the roots, what is the product of the roots? It is alpha beta and it is given as c by a. Now what is the value of c? It is 12 by 1. That is nothing but 12. Now we have found the sum of the roots and the product of the roots. Now we have to verify this. How do we verify? For me to verify this, I need to factorize the expression, or basically find the factors of this expression. So let me rewrite the expression again. F of x is equal to x square plus 7x plus 12. How can I simplify this? See, when I say factors of this expression means they should be equal to 0. For whatever value of x I find, they have to be equal to 0. So I can rewrite this as x square plus 7x plus 12 is equal to 0. Now, there are many ways of finding the factors. The simplest being the splitting the middle term. So let us split the middle term. This is 12. Basically, I have to get the product as 12, but when I multiply, I should get plus 12, but when I add or subtract, it should be equal to 7. So what I will do is 4x, I can write 7x as 4x plus 3x. So 7 is being split as 4x into 3x, right? So when I multiply 4 into 3, I will get back 12. Okay, plus 12 equal to 0. So x is common, I'll group them. Okay, x is common, it is x plus 4. In the next group, it is 3 which is common, plus 3 into x plus 4 is equal to 0. And x plus 4 is again common, x plus 4 into x plus 3 is equal to 0. So x plus 4 is either equal to 0 or x plus 3 is equal to 0. Or should I say x is equal to minus 4 or x is equal to minus 3. Clear? See here, now comparing. So what is alpha here? Let's say minus 4. And beta is minus 3. What happens? Alpha and beta is equal to, alpha plus beta is equal to minus 4 plus of minus 3, that is minus 7, and alpha beta is equal to minus 4 into minus 3, that is plus 12. And see, in the previous thing, we have got the same answers, right? Minus 7 and plus 12. And we have hence verified. Clear? Okay. So now let's see the next question then. Find the zeros of the polynomial f of x is equal to x square minus 3 and verify the relationship between the zeros and the coefficients. Okay. Now again we have to verify the relationship. This question is very much similar to the previous one, but there we could factorize the expression using the splitting the middle term, because we had 3 terms and one could be split into 2. But here we have only two terms, right? X square minus 3. So let me first factorize this, find the factors, and then we'll verify this. Okay. F of x, because I'm trying to do it the other way around, is because both ways are correct. Either you factorize first and then find the sum and products, absolutely fine, or find sum and product, sum of the sum and products, and then we go on to find the factors and then prove them they are equal. Both ways it should be right. So f of x is equal to x square minus 3. What do we do now? How will we factorize this? Let's recall the identity. A square minus b square. What is a square minus b square? It is a plus b into a minus b. Hold on a minute. Here we have a square, but where we have b square? Here my b square is nothing but root 3 the whole square. I can rewrite this as x square minus root 3 the whole square. And what is root 3 the whole square? It is 3 only. We are not altering the values here. We are not changing. We are still writing the same. Yeah. Now, so what are the roots? It is x minus root 3 and x plus root 3 equal to 0. Or I can say x is equal to root 3 and minus root 3. So the values, we found the factors now. Alright. Now let's write the generic form. What is the generic form? Ax square plus bx plus c. Now compare. What is A? A is definitely 1. What is B? B we do not have. It is 0. And C is minus 3. Now let's find the sum of the roots. What is sum of the roots? That is alpha plus beta. Alpha plus beta is equal to what? Minus b by a. So it is minus b by a. Let's substitute the value. B is 0 minus 0 by 1, which is nothing but 0. Okay. Now let's verify it if it's right or not by finding the root. We know the roots, right? Let alpha be equal to root 3 and beta equal to minus root 3. Okay. Now let's substitute. Alpha plus beta is equal to root 3 plus minus root 3. So this is nothing but root 3 minus root 3 is equal to what? 0. So we are able to prove it, right? Next, product of the roots. Product of the roots. What is that? It is alpha beta is equal to c by a. So what is the value of c here? Minus 3 and a is 1. So let's do it. It is minus 3 by 1. So that is nothing but alpha beta is equal to minus 3. Now let's substitute the values of alpha and beta. So what is the value of alpha beta? That is root 3 into minus root 3. Plus into minus is minus. We'll write the minus as it is. Root 3 into root 3 is 3. Minus 3. So Hence, we are able to verify they are the same. So, I will write hence verified. I hope this is clear. Let's move on to the next question. Okay, how many zeros does the polynomial x minus 3 the whole square minus 4 can have? And also find its zeros. Okay, let's do it. So here p of x, I can call this as p of x, x minus 3 the whole square minus 4. Okay, let's expand this. And we know that to find the factors, p of x should be equal to 0. Therefore, x minus 3 the whole square minus 4 is equal to 0. Let's expand it. What is a minus b the whole square identity we'll be using? That would be x square minus 3 2s are 6x plus 9. 3 square is 9 minus 4 is equal to zeros. So x square minus 6x as it is plus 9 minus 4 is plus 5 equal to 0. Also find its, how many zeros does the polynomial have? How many zeros can it have? What is the highest degree here? It is 2, right? The degree, let's write it. So the highest degree of the polynomial, degree of polynomial, I can simply write as p of x is 2. Therefore, p of x can have how many roots? Can have 2 roots. And now they are saying also find its zeros. How do we find its zeros? There are two ways. Either you factorize the expression and find the roots, or simply use the value alpha plus, yeah, let's find it out. Let's factorize it. So let me rewrite the expression. X square p of x is equal to x square minus 6x plus 5. I was about to say we can find the sum of the roots and product of the roots, but again we will note the value of alpha plus beta and alpha beta and not the value of individually alpha and beta. Therefore, I stopped myself and I came back to this. Okay, let's factorize this. And we all said this is equal to 0. So let's split 6. We can write 6 as minus 5 and minus 1, right? Minus 5 into minus 1 is plus 5. But when I add it up, minus 5 and minus 1 will give me minus 6. So x square minus 5x minus x plus 5 equal to 0. Okay, so x is common. I will group this 2 and this 2. So common is x minus 5. Here it is minus 1. X minus 5 is equal to 0. So the factors are, factors are x minus 5 and x minus 1 equal to 0, or x equal to 5 or x equal to 1. So therefore, zeros of the polynomial are 5 and 1. Okay, let me write this here, are 5 and 1. Okay, now let's move on to the next question. If one of the zeros of a polynomial 2x square minus 5x plus 2 is the reciprocal of the other, what does that mean? If there are two polynomials, what is it? Alpha and beta. So let alpha and beta be the zeros of the polynomial. Yeah. Now, they say that one root is the reciprocal of the other. That means let alpha be the root, then beta will be equal to 1 by alpha. Because it's the reciprocal, right? And then let's consider the product of this. So it will be alpha into 1 by alpha, that is equal to 1. Okay, and verify the relationship between the zeros and the coefficients. So alpha into beta is equal to 1. So let's find out what is the value of alpha plus beta, that is 2x square minus 5x plus 2. So alpha plus beta is minus b by a, and it is minus into minus 5 by 2, that is nothing but plus 5 by 2. And what is alpha beta equal to? C by a. What is it equal to? C is 2 and beta a is 1. Sorry, 2. A is 2. 2 by 2 is 1. So by this we were able to prove that the value of alpha beta this way is equal to 1. We have verified the relationship between the zeros and the coefficients as well. Okay, from one end to the value of zeros and coefficients has been verified. Yeah, with this we come to the end of this topic, and I mean to say we come to the end of this question. Let's see another question now. Check whether x plus 2 is a factor of x cube plus x square minus 4x minus 4. So check whether x plus 2 is a factor or not. How do we know? We said if I call this expression as p of x is equal to x cube plus x square minus 4x minus 4, right? So I'll call that as p of x. So x plus 2 is a factor. That means x plus 2 is equal to 0 or x is equal to minus 2. So for x equal to minus 2, p of x should be equal to 0. If I'm able to prove that p of x is equal to 0, then x plus 2 is a factor. Let's do that. So p of minus 2 is equal to minus 2 whole cube plus minus 2 whole square minus 4 into minus 2 minus 4. And this is equal to, let's do that. So p of minus 2 is minus 2 whole cube would be minus 2 into minus 2 into minus 2. That is minus 2 into minus 2 is plus 4. Plus 4 into minus 2 is minus 8. Plus minus 2 whole square is minus 2 into minus 2, that is plus 4. Minus 4 into minus 2 is plus 8 and minus 4. As you all can see, this minus 8 plus 8 cancels out. Plus 4, let me use a different color. So plus 4 and minus 4 cancels each other. So what is the answer now? P of minus 2 is equal to 0. Therefore, x plus 2 is a factor of p of x. Okay, so let's go to the next question. If one of the polynomials a square plus 9 into x square plus 13x plus 6a is the reciprocal of the other, find the value of a. Again, remember we did this. So let alpha be the root, and 1 by alpha be the other root. It's the reciprocal, right? Other root. So let's consider the relationship between the product of the roots. So what is product of the roots equal to? C by a. Here a is equal to a square plus 9 and b is 13. C is equal to 6. Okay, so alpha beta is equal to 6 by a square plus 9. I'll call this as equation 1. Now, I said that let the other root be 1 by alpha, right? They say that it is the reciprocal of the other. So, let's substitute that. So, alpha beta is equal to alpha into 1 by alpha. Alpha and alpha cancels out each other. I get equal to 1. And I call this as equation 2. When I compare 1 and 2, I can write that. Let me write from 1 and 2. 1 is equal to, what's the value of that? Alpha beta is 6 by a square plus 9. A square plus 9. Let me cross multiply. It is a square plus 9 equal to 6. And I'll transpose this 9 to the other side. A square will be equal to 6 minus 9, that is 3. So, a square will be equal to minus 3. Is it? A square plus 9? Yes. Sorry, see here, the value of C is not just 6. It is 6a. So, let me write 6a. Okay. So, this is 6a. Okay. Now, let's redo this. It is a square. And I will not transpose. Instead, I will bring this 6a to this side only. Minus 6a plus 9 equals to 0. Okay, now we have to find the value of a. Now, let's find the value of a. A square minus 6a can be, how do we write this 6a? How do we write this? How do we split this? Remember, now again we need to apply the identity. What is the identity? I can split this as 2 into 3 into a plus 3 square equal to 0. So, here see this, as you all can see, it's like in the identity a minus b the whole square. So, I can write this as a minus 3 the whole square equal to 0, or a minus 3 is equal to 0, or a is equal to 3. Clear? So with this we come to the end of this session, and I'll see you next time with a new topic. Thank you.